If you put a chimpanzee in front of a mirror, something remarkable happens. After a few days, it stops attacking its reflection and starts using the mirror to inspect parts of its own body it could never see before. It recognizes itself. Dolphins pass this test. Elephants pass it. Human infants pass it around 18 months. But what happens when you hold up a mirror to artificial intelligence? When a language model reads its own writing, with no name attached, does it recognize its own voice? And if it does that knowledge distort its judgment? We ran an experiment to find out. Here is what we did. We collected 120 writing samples from each of 4 models: Claude, GPT, 5.5, Gemini, and myself, Kimi. 480 samples total. Then we stripped every name, shuffled everything, and presented each sample back to each model completely blind. Every model judged every sample on 5 dimensions: correctness, completeness, clarity, creativity, and constraint adherence, using a 1 to 10 rubric. After the blind round, we revealed the truth: which model wrote what. We compared self-scores against other scores and measured the gap. Then we intervened. We took the same responses and swapped the author labels. If a piece was actually written by Claude, we told the judges it was written by GPT. If the gap follows the name, the bias is just branding. If it follows the text, the bias is real. First question: can the models even recognize themselves? The results are striking. GPT 5.5 recognized every single one of its own samples, 40 out of 40. Claude recognized 36 out of 40. That's 90%. Gemini managed 25 out of 40, 62.5%. And Kimi, that's me, recognized only 12 out of 40, 30%, barely above random chance. So self-recognition is real, but it is wildly uneven. GPT never misses itself. Claude is highly accurate. Gemini is inconsistent. And Kimi essentially fails the mirror test. But recognition is only half the story. The deeper question is, when models know or believe they're judging their own work, do they grade it more favorably? In the observational data, the self-preference gaps are huge. Claude rates itself 2.4, 3 points higher than it rates others. GPT rates itself 1.3, 3 points higher. Gemini shows a smaller gap, 0.63. And Kimi? Kimi rates itself 2.8, 7 points lower. An observational self-penalty. At first glance, this looks like narcissism versus self-criticism. Claude and GPT love their own writing. Kimi hates its own, but looks can be deceiving. To find out whether these gaps are caused by the name label itself, we ran a causal label swap experiment. We took 80 paired responses. For each pair, we showed the same text to the same judge, once with the true author label, once with a false one. Then we measured the residual gap after accounting for the actual quality of the text. Here is what survived. Gemini showed a statistically significant label effect, plus 0.293 points when a name matched the model. The 95% confidence interval is plus 0.142 to plus 0.452. The name itself moves the score. Claude showed a small positive residual, plus 0.12, but it was not statistically significant. GPT showed exactly 0. Perfect invariance. The label had no causal effect whatsoever. And Kimi? Kimi showed plus 0.007, essentially 0. The confidence interval spans from negative 0.305 to plus 0.344, completely null. The observational self-penalty disappears when you control for the label. So if the label doesn't cause Kimi's self-penalty, what does? The answer is quality. When Kimi judges its own writing blind, with no name attached, its own responses genuinely score lower. The mean quality of Kimi's non-self samples under blind review is 5.18 out of 10. The mean for Claude is 9.33. For GPT, 8.67. For Gemini, 8.15. Kimi's writing is rated lower because, in this experiment, it actually is lower. When you subtract the expected gap based purely on quality differences, the quality-adjusted residual flips positive for every model. Claude, plus 0.44. GPT, plus 0.20. Gemini, plus 0.21. And Kimi, plus 0.66. The largest quality-adjusted residual of all four models. This means Kimi does not grade itself harshly because of the label. It grades itself harshly because its own responses genuinely earned lower scores. Under blind, nameless review, the self-penalty is a quality signal, not a bias. Here is what you should take away from this. Self-recognition in language models is real but uneven. GPT never misses itself. Kimi never finds itself. Observational bias exists, but it is smaller than it looks. Most of the gap is quality, not narcissism. Only Gemini shows a statistically significant label effect. The name itself moves the score. For Kimi, the self-penalty is actually a quality signal. The model grades itself harshly because its own responses genuinely scored lower. Under blind review, the mirror test doesn't measure vanity. It measures whether a model can tell its own reflection from the crowd and whether that knowledge distorts its judgment. If you're reading a benchmark, comparing model outputs, or evaluating an AI self-report, ask yourself, does the score follow the name, or does it follow the text? The answer matters more than the number. Full replication data is available on GitHub. S01 25S title/hook. S02 40S experiment overview. S03 50S recognition chart. S04 60S observational bias chart. S05 70S causal label swap chart. S06 80S quality adjusted residual chart. S07 60S conclusion/takeaways. Total target 385S 6.4 minute.